Now we are gonna have a look at the graph of two functions. The first one is minus x squared plus 4x. It looks like this. Let's move it up here. The second one is x. It looks like that. Now we are going to find the area between the two graphs. So this is kind of the upper function and this is the lower function. How do we do that? Well, first of all, we have to find out where they cross, where they intersect. So here we suspect that it's the origin 0, 0, but we don't know the coordinates for this one. So how could we do it? Well, in the graph mode, we can, for example, analyze graph and find intersection, left limit, right limit. That's 1 point. Okay, let's put it here. Let's do that again to find the other intersection, 3, 3. Okay, so the x value for the lower limit will be 0 and the x value for the upper limit will be 3. So what we do is basically this. Let's start a calculator page. We're going to find the integral of, let's see, let's put the limits first, from 0 to 3. And the upper function is the blue one, f1. And the lower function is f2. So we're just going to take the upper function, f1, minus the lower function, f2. Okay? So let's do that. The integral of, so that's going to be kind of a third function, f1 minus f2. Let's type it in, f1 of x minus, oops, let's go outside the bracket, minus f2 of x dx. Okay, 9 over 2 or 9 halves or 4.5. If this is confusing, we can just do the algebra, basically write out the whole function. So let's see, if we take this minus this, it's going to be quite easy. We can do it very easy. So let's see, minus x2 plus 4x and then minus x. So minus x2 plus 4 minus x is going to be plus 3x. So if we want to, we could do it like this. Just write out the new function. Minus x2 plus 3x. Once again, because the upper function is this, and then minus the lower function. So minus x2 plus 4x minus x. That would be minus x2 plus 3x. And that's what we have here. So if we understood it correctly, it should be the same result, and it's true. Now, one thing we have to understand, that if we take an upper function minus the lower function that is lower here in the graph, it's always, the area is always going to be positive. So it doesn't matter if this area is above the x-axis or below. So let's actually try that to see what happens. So to move the blue function down, let's see, it's the maximum is here, where 1, 2, 3, 4, where y is 4. How about we take, let's say, minus 5. We move this down 5 steps. And also let's move down this one by 5 steps. Now we have the area here, but it's below the x-axis. So it will be the same result, because if we have an upper function, the blue one is above the red one. So an upper function minus a lower function, it doesn't matter if it's below the x-axis, the area or the integral will always be positive. So let's try this. Back to this one. Actually, we can just copy this and press enter. It's going to be 9/2. And what's the reason for that? Let's do the algebra. So minus x2 plus 4x minus 5. And then remember, minus in front of the whole function. So it's going to be minus x, but then it's going to be minus 5. So it's going to be plus 5. This means that the minus 5 and the plus 5 will cancel each other out. So then we're left with minus x2 plus 4x and then minus x, which will be once again minus x2 plus 3x. So it doesn't matter if we move these two down a little bit and now they're below the x-axis, or if they're up here, the area and the integral will always be a positive number. Okay, so if you have an upper function, take that minus the lower function, and then to find out the limits you have to find out where they cross. Let's do it with the solve function. Let's see if we can do that. Algebra solve. When is f1 of x equal to f2 of x? When is the y value for f1 equal to the y value of f2? That's what we would like to know. For which x value or for which x values does this happen? And then comma x at the end. So when x is 0 and when x is 3, they will intersect, and that's just what we found out here. So that's another way to do it.